Is it working? Is it working? Are things working? I think my last live, which I called cosmology because I thought I would talk about cosmology, froze up and kept repeating the same little clip. You can see me? Hi, Adventures of Austin. Can you see me? Am I a thing? Thank you so much for being here. Can you please like the live? Oh, God. Can we get 10 likes? I just want to cry now. It's been awful. Let me have my protein shake. Just 1 second. As I was saying, Mars is okay, but I don't want to go to Mars. I want to be here on Earth, and thank you so much for liking. Thank you. Thank you for the hearts. Thank you for being here. Gosh. Ugh. Okay. I don't know what I'm doing, sniffling or crying. I just feel like things are not working very well right now. Okay. All right. Oh, thank you so much for liking and subscribing and sharing and everything. Can you hear me? Adventures of Austin, can you say more things? Wait, what? What is this? Hi, Psyche Corey. You can hear me? Oh, thank you. Thank you, everybody. Welcome to my live, which is hopefully alive. Thank you so much, everyone, for being here. Thank you, thank you, thank you. Thank you, universe. Thank you. Psyche Corey, hello. How are you? How are you doing today? I'm okay. I am also good. Well, I don't even see my freaking live on YouTube anymore, so I can't share it. Chill. Are you telling me to chill? Excusez-moi. I will do what I want. Chill? You chill. Hi. Welcome to the live. It's not showing me my live. Oh, there it is. It wasn't showing me my live. Now I can hear me. Hi, Cypher. Cypher says sassy. Hello, Cypher. Camille says you witch. That's better than something else that I could be. Are you a child or just psycho? Says Cypher. What was that evil goofy laugh? J Daddy. Okay, hello. What was that evil laugh? Shelly. Hi, Shelly. Shelly Durham says hi. Facade says hi. Plenty Hetty says sometimes when my parents aren't home, I dig a hole in the garden and pretend to be a carrot. Goodness gracious me. Hi, TJ. Camille says that's what I'm saying. Witch? I am a witch. Should I pull out some tarot cards and do tarot readings for you guys? I'm kind of a witch, actually. Kinda. That accent, though. Which accent? I have like 10. Which accent, Jay? I have 10. Ooh, can you please like the live? Can we get 20 likes? You guys are being a little useless. Can you like the live at least? Can you double tap? Psyche Corey says LMAO. Psyche Corey, Psyche Corey, you haven't been here enough. You haven't been to my lives enough. Google Rewrites says no. Okay, Google Rewrites, thank you for declaring. Batbok Bapau says hey beta. Plenty Henny says
I didn't understand. But I found something
Hey
else.
Google,
Do you want...
shut up! Because of your username rewrites, my Google is getting confused. Gosh! It's the retrograde. Is there a Mercury retrograde? I'm sure astrology has a reason, but right now we're doing astronomy. Cypher says you should pray to Jesus. I'm scared. Punjabi accent. Punjabi accent? What do you mean? I don't have like accents for delivery for you. You know what I mean? Get your mind checked. Rewrite says astrology, cosmology. I don't know what are you saying? Astrology is less important. I mean, sure, there's more people who do astrology than cosmology. When I studied cosmology, people thought it was cosmetology. Okay, so don't tell me about what's more important. I know I like cosmology, but most people think of it as cosmetics. Where are you from? I'm from Earth. We were talking about Mars just now, but I'm not from Mars. I'm from Earth. You were definitely homeschooled. Your accent is something between do not redeem the card, Starbucks, computer science professor at YouTube videos. Aww! Thank you. Thank you so much. Thank you. Thank you. Thank you for taking the time. Your accent is adorable. See, Rewrites is saying one good thing today. One good thing. Can you please double type? Double type. Double tap? Can we get 20 likes? Where are my mods? Nothing is... I just want to tell you about Mars and be done. What time is it? 12:50. You know what, guys? Let's talk about why Mars is a pretty okay planet, and then we can say good night, because I don't have the patience for you guys anymore. It's slight, but in the best way. People notice it doesn't have... What doesn't have trillions? Oh, Mars does not have plastic. Oh, Mars is more natural. That's right, guys. Mars is more natural, kind of like me. They see beauty. What's the planet before Neptune? It's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. You look like one of the hyenas of the Lion King. Thank you, Plenty Henny. Mike D says, I love you. Aww. Mike D, I hope you're 10, because then I can say, I love you too, baby. Rewrites says, yes, exactly. Oh, Mars doesn't have plastic. Mars doesn't have oceans to submerge the plastic in. Mars doesn't have people. That's the best part. Let's go to Mars, actually. Mars is a chocolate bar, kind of like you. Aw. Well, my favorite chocolate is something else. It's something else. It's got coconut in it. I'm a solid 7, dear. I was talking about age. I hope your age is like 7 or 10 or 8. That you know of. Sophia. Hello. Hi, Sophia. Sophia Elizabeth says hi. Rewrite says Mounds is underrated. I love my chocolate with coconut. 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 Sophia says hello. What's your age? She likes BBC. I don't know what that means. Is that an insult? Because BBC is like some television channel, right? So I don't even know what is wrong with you, Plenty Henny, with 2 N's. Weird. You're weird. Rewrites history says 29, 45. You're 45 or I'm 45? I'd rather me be 45 actually, because I don't want some 45-year-old to tell me that they love me. Like, for real. I hope I'm 45. Not you. I hope you're 4 or 5, not 45. Jesus. Gosh. Okay. Where is the chapter I want? One second. I'm losing it. I'm a little unhinged today. It's a little unhinging of a day today. 2:32, where are you? Scooby-Dooby-Doo, where are you? We've got some calcium for you. Come on, Dooby-Doo, where are you? You remind me of Jasmine? Who the frick is that? Jasmine Cherny. Who is that? Seeing Miedo says, what's wrong? Saddest planet? Oh, no. Definitely not. Okay. To the naked eye, Mars, shown as high resolution in color figure 7, we will look at this figure later, has a perceptibly reddish color. Perceptibly reddish. So, it was a natural series of associations that led ancient astronomers to associate the red planet Mars because remember, Mars is reddish. With the god of war. So by the way, reddish as in R-E-D-D-I-S-H, obviously. Do you even understand English? So, you would look, oh! All right. Okay. So if your birthday is in April, or you're in Aries, you're ruled by the god of war. In other words, you're ruled by Mars, actually. So, that's the planet we're going to discuss right now. It was a natural series of associations that led ancient astronomers to associate the red planet Mars with the god of war. Red meaning blood, meaning war god. Okay? So that's Mars. The ancient fascination with Mars has lasted to the present day. So people were fascinated in the past with Mars, especially the whole being red thing. And people are still fascinated with Mars today. And some people, of course, want to move there, and which is totally fine. I want more and more people out of here, out of the Earth. Mars has an orbit with A equal to 1.52 astronomical units. So Mars is at a distance of 1.52 astronomical units from the sun. Like I said, we are at 1 astronomical units away from the sun. Mars is 1.52, so it's farther away, obviously. Okay, and hence an orbital period of 1.88 years. So the orbital period of Mars is 1.88 years. Ours is a year, as you know, it's longer. Mars is the terrestrial planet farthest from the sun. So by the way, what is the September one? Virgo? Is that your sign, you mean? Zodiac sign? 9/11? Oh my gosh. Like how you said Mars was April. Mars was April? What do you mean? April? Yeah. Aries is April, and Mars is the god that rules Aries or something. Hijab? What the frick, Jay? You better get it under control. My mods are not here, but I can be strict too. My mods are way more strict than me, but I can be very strict. I'm gonna ignore you for now, but you better not interrupt me anymore. You bad. Sit down. Good. And stay seated and shut up. I'm not laughing about you. I'm still upset. I'm upset. I'm laughing because it has come to this. It has come to this. Anyway, so yeah, okay. We will keep going. So Mars, the terrestrial planets are Mercury, Venus, Earth, and Mars. The next set of planets, Jupiter onwards, are called Jovian planets, okay? We've covered the planets in details before, so this is all review for the people who have been here before, who have come to class and not been weird. But I'm just gonna review Mars with you tonight before bed. But basically, the terrestrial planets are rocky planets. These have rock in them as a substantial part of the planet. These are, again, Mercury, Venus, Earth, and Mars. And Mars is, of course, the farthest terrestrial planet. So that also tells you something about how I was saying non-gas giants. Yes. So the rocky planets, Mars is the last one. So it's going to be the coldest one, pretty much. Okay? So let's see. Mars is the terrestrial planet farthest from the sun and hence the terrestrial planet with the coldest surface. See? Mars has a number of superficial similarities to Earth. So there are some superficial, this is what I meant earlier. There are some surface level similarities with Earth. It's when you consider the mass and the size and all that and the distance from the sun, actually Venus is more similar to Earth. But there are some other superficial similarities that Earth has with Mars, which are the redeeming qualities or the meritorious qualities of Mars when we consider moving somewhere. When are you gonna go live again? Tomorrow. Why? Tomorrow. Don't be needy and just get notifications. Just subscribe. Subscribe. Press the bell icon. I don't know. Come to the live. This is a protein shake with milk. This is protein in, this is, I mean, I guess it's chocolate flavored protein powder in milk. Okay, because I worked out. Sometimes I remember to drink it, sometimes I don't. Strawberry milkshake, no. It's a protein powder. Gosh, oh gosh. I was wondering because I have to go to bed. Sorry. Thank you. Please do come again to the live. I'm subscribed. I just forgot. I was so close. Thank you everybody for your patience on this rather fiery night. Actually, I'm a Libra and today is my half birthday. April 17th. Well, it might be 18th already. I don't freaking know. But today's my half birthday, so I'm the opposite to the Aries sign, but I'm feeling like an Aries today, where I just want to like, be the god of war. You know what I mean? Or ruled by the god of war. Not the god of war. I'm not the god of war. I am more peaceful and harmonious than that. But sometimes you gotta be an Aries, you know, and just like win the battles. You know what I mean? All right, forget it. Mars has a number of superficial similarities to Earth. Its equator is tilted by 25 degrees relative to its orbital plane. So this is very important. Its tilt is close to the number that is our tilt. Our tilt is 23.5 degrees. Mars's tilt is 25 degrees. As you know, our tilt, as in the tilt of our orbit, orbital plane, of course, determines our seasons. So Mars is gonna have similar seasons. So that's pretty cool. Okay? So Mars has a number of superficial similarities. Its equator is tilted by 25 degrees relative to its orbital plane. This is similar to the Earth's tilt of 23.5 degrees, which is cool, which is really nice. Be a lover, not a fighter. Oh, shut up. Thank you, though. Thank you so much for being here. Can we get 10 likes? Thus, the seasonal variations on Mars are similar to those on Earth, only with seasons 88% longer, thanks to the longer Martian orbital period. So, the seasonal variations, like having seasons, summer, winter, fall, spring, The seasonal variations on Mars is similar to that of Earth, but Mars's year is longer. So it's kind of like the same sort of seasons, or the fact that you have seasons, but over the course of a longer year. And why? Because the tilt of Mars is similar to the tilt of Earth, which is very interesting. It's very interesting. Very, 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 very cool. So that is one of the similarities. Like if you go to Mars and you like seasons, you're not going to miss seasons. You're going to still have seasons in Mars, but they're going to be colder. Just saying. Like the summers are going to be cold. So if you like cool summers, you might like Mars. I'm not sure it has I'm not sure it has seasons, does it? Right, but I'm selling Mars to you because maybe some of you will move there and free up the Earth real estate and make housing prices come down maybe. I'm not sure it has seasons. Did you go to college to learn all of this? I went to a lot of school, yes. What season do you like? But also I read this book and learned all this. You know, you don't have to go to college to learn all this. You can just read these books yourself. Off the planet. Damn, kicking me out. I hate math and physics. It's headache. Well, you're a headache for FFE. This book is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson, both authors that were my professors and colleagues when I was in grad school at Ohio State. So, keeping on over here. Thus, the seasonal variations on Mars are similar to those on Earth. Oh, somebody asked what my favorite season is. It's fall, which is when my birthday is. Okay. The length of the solar day on Mars is 24 hours, 40 minutes. This is only 3% longer than the Earth's solar day. Although Mars has an escape speed comparable to that of Mercury, its daytime temperatures are much lower, my dears. The daytime temperatures are much lower. It's the best one. Which one is the best one? What do you mean? So, the length of the solar day on Mars is 24 hours, 40 minutes. This is another, can I speak? This is another similarity. Ooh, can we get 10 likes? Another similarity is that the length of the solar day on Mars is 24 hours and 40 minutes, which is only 3% longer than the Earth's solar day. Although Mars has an escape speed comparable to that of Mercury, its daytime temperatures are much lower. Thus, Mars has been able to retain an atmosphere. Because remember how Mercury's atmosphere is very iffy. It's very on and off, if you know what I mean. Mercury is very close to the sun and it's very much smaller, so it doesn't retain an atmosphere very well. But it will have on and off atmosphere because of its proximity to the sun, and some of the solar stuff will get kind of trapped near Mercury, giving it sort of a transient atmosphere. This is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson. I cover a lot of topics from this book on my lives, so you could just come to my live streams and be covered. Also, if you're interested in all of this, you should subscribe, and also you should check out the older live streams, which will have a lot of these topics covered in those episodes already. So I've been going live for a while, so you can always go and check out these topics in older lives and just listen to them in the background while you're doing dishes or something, So you don't need to buy the book because it's pretty much covered in the lives. A lot of these discussions we've covered already. We were actually not on this book right now, but I came to it because of the questions about Mars and whatnot. And thank you so much for being here. And can we get 10 likes? Okay. So another similarity with Earth is that the length of the solar day on Mars is 24 hours and 40 minutes, which is very close to our 24 hours. Although Mars, as in our solar day, although Mars has an escape speed comparable to that of Mercury. So Mars is very much smaller than Earth. So its escape speed is comparable to that of Mercury. Its daytime temperatures are much lower. So because its daytime temperatures are much lower because of being so far away from the sun, so it's not like its atmosphere is like constantly blown away like on Mercury, right? So although Mars, thank you for the emojis, thank you for the hearts and all that stuff, engaging and whatnot. Thank you so much, really appreciate it. Okay, so although Mars has an escape speed comparable to that of Mercury, its daytime temperatures are much lower. Thus, Mars has been able to retain an atmosphere, which is very nice. Having an atmosphere is good. Unless it's poisonous like on Venus, then it's not as good. But having some kind of atmosphere is actually nice because that also makes it kind of similar to Earth. However, the air on Mars is thin. The average air pressure at the surface of Mars is 0.006 atmospheres. Compare this to the pressure on Earth at sea level, which is an atmosphere, 1 atmosphere, versus 0.006 atmosphere. So the pressure is very low there. The Martian atmosphere is 95% carbon dioxide, similar to the atmosphere of Venus. So also kind of a bummer is that it has a ton of carbon dioxide without the liquid water. There is little water vapor in the atmosphere of Mars. This is because UV light dissociates it. Mars with no oxygen in its atmosphere doesn't have an ozone layer to absorb the UV light. So bummer, a lot of carbon dioxide. I mean, we had it too. Earth had a lot of carbon dioxide too, but because of our liquid oceans, we were able to trap some of that carbon dioxide in the water and convert it to limestone. And that's actually how we cleaned up our atmosphere over the ages. And here we are now to breathe it and pollute it. So, a water molecule is dissociated into hydrogen molecule and an oxygen atom. The low mass hydrogen molecule escapes into space and the oxygen combines with iron in the Martian soil, making the ferric oxide that gives Mars its distinctive reddish color. So the distinctive reddish color is basically rust, right? It's iron oxide, it's ferric oxide. If you just had iron, that wouldn't do it. It's really the combination. It's really the chemistry with oxygen, which makes that rust, just like we have rust here on Earth too. So that's the reddish color. The surface of Mars is about 44% silicon dioxide, which is sand. So this is where what I meant about the surface of Mars being kind of similar to ours. Our surface has a lot of silicon dioxide as well, like sand, beaches, things like that, right? So Mars's surface is kind of similar to ours. So in that sense, if you walk around on Mars, you'll feel lighter and you'll think that it's, oh, this is so nice and sandy. So you might like it in that sense, okay? It's similar in that sense. So 44% silicon dioxide and 19% ferric oxide, which is the rust. The remainder is a mix of various minerals. So even though it has that reddish color because of the rust, it has more sand. And so it's a lot like us. But remember, we have liquid water. So from a distance, we look like a blue ball. And from a distance, Mars looks like a red ball because of the rust in its surface. Okay? Okay. So Martian clouds are thin and wispy. So, we have thick clouds here in the Earth's atmosphere. Venus has clouds too, but these are pretty thick. Here on Mars, there are thin, wispy, little light clouds, like cirrus clouds on Earth. Both, they're made of solid ice crystals, not liquid droplets, because again, remember, it's cold. So somebody was asking about the water on Mars earlier. And it's cold, so water is not gonna exist in its liquid water form so easily on Mars, okay? So ice crystals in the clouds instead of liquid droplets. The clouds of Mars are made of both frozen water and frozen carbon dioxide. So frozen water as well as frozen carbon dioxide is basically what's in the clouds of Mars. Okay. Geologically speaking, the two hemispheres of Mars are very different from each other. That's the other thing. These are details about Mars. It's not like you have to pick, you don't have to like both hemispheres. Say if you go to Mars, you can pick one, you pick two, a sandwich, Panera bread style, and just stick with the hemisphere you like, okay? And just leave Earth so that the real estate prices can go down here. The northern hemisphere, which is relatively low in elevation, contains few craters and shows signs of recent volcanic activity, like the larger terrestrial planets Earth and Venus. The southern hemisphere, which is relatively high in elevation, contains many craters and is geologically dead. So this is probably the hemisphere you would want to be in if you don't want volcanoes. No, you. You! So if you don't want to deal with volcanoes, if you want geological safety, if you want geologically boring spots, then the southern hemisphere of Mars is where you'll be at. But please do make your way, headway over there. The southern hemisphere, which is relatively high in elevation, contains many craters and is geologically dead, like the smaller terrestrial planet Mercury and like the moon. Hi, Shona. Hi, Fuji Baba. Fuji Baba is waking up and I want to say hi to him. From his little nap. Shona, love you, baby. Thank you, God. There are a pair of strikingly large geological features on Mars. Olympus Mons is an enormous shield volcano. No, Baji, don't drink my protein shake, Baji. Shona. Shona. Olympus Mons is an enormous shield volcano about 600 kilometers across, so huge shield volcano, 600 kilometers across and 25 kilometers high. By contrast, Mauna Loa, the largest shield volcano on Earth, is only about 200 kilometers across and rises only 9 kilometers above the ocean floor. So an enormous shield volcano is part of the Mars I don't even know what to say, geography. The enormous size of Olympus Mons shows that there's little plate motion on Mars, and one location of the crust can stay above a hot spot on the mantle for a long time. So this is the thing. Why do we have this enormous shield volcano, which is about 600 kilometers across and 25 kilometers high? It means that on Mars, there is not as much plate motion. Like, you know how our plates move and stuff and we have earthquakes and whatnot? Thank you for being here. Can we get 10 likes? That sort of stuff is going to be less on Mars, which means that one location of the crust can stay above a hot spot. Because, I mean, the Olympus Mons thing happened because of a hot spot, right? It's a volcanic eruption, came out of the mantle, but it's so big, it's so long and so high, meaning that it didn't get broken up, meaning that it's kind of stable. So it means that there is little plate motion, little things that are topsy-turvying this stuff that's on the mantle. Like, say you make a volcanic eruption and you do all this stuff and you've created this huge shield volcano that's huge, but how did it get so huge? And how did it get so high? It would have happened again and again, right? It's not a one-time thing necessarily. So whenever a volcano comes out and erupts a ton, it's not like it's just gonna, do it once and that's it. It's probably done it over and over, right? Over time. But if there were a lot of shaking things, a lot of things shaking up that stuff, a lot of things that are topsy-turvying this shield volcano eruption result, like earthquakes, like we have earthquakes. If there were Marsquakes, then it wouldn't have become so big. So its huge size basically implies that there is very little plate motion on Mars, and one location of the crust can stay above a hot spot on the mantle for a long time. There are hot spots, and on top of it, you can just create a humongous Olympus Mons without disturbance. There is little cratering on the slopes of Olympus Mons, indicating that it is geologically young. Because remember, impact craters were formed when planetesimals were still hitting everybody in the solar frickin' system. So we've talked about this before. Cratering is actually a very old event. It happened, I forget, it might have been about 1 billion years ago that it happened. So, like, you know how the moon has a bunch of craters? So the moon's surface is actually older than ours. Like, ours has gone through more geological things, and we have sort of we've kind of lost the craters because more things have happened to either smooth out the craters, pave them out, etc., right? But if you are something that is not very geologically active, like our moon, then you're gonna retain those craters from a while ago, from like a freaking billion years ago or something. And you're gonna basically have this like olderness to you, older surface feature, retaining that, right? Because you're geologically dead. You don't have volcanoes, you don't have oceans, you don't have a lot of erosion, you don't have an atmosphere, you don't have wind, rain, all this stuff constantly making you geologically active like what we have here on Earth. I mean, the most geologically active site in the solar system is actually a moon of Jupiter, but that's a different matter. Basically, all of that is to say that if something doesn't have a ton of cratering, it means that it's a newer thing. If something has a ton of cratering, it means it's an older thing, because there was an era of cratering in our solar system when things were still kind of forming, and then there were these things called planetesimals, basically debris in the solar system before things kind of settled down more to the current configuration. All this debris would just random like hit us all the freaking time. Like we would get hit all the time. Moon got hit, we got hit, everybody got hit. But if you still, to this date, show a ton of cratering, what that means is that you didn't do things in the meantime, geologically, to basically cover up the craters, right? Like volcanoes will pave them, erosion will erode them away or give them a different shape, etc. So the cratering is actually a clue as far as the age of that surface, right? So this is what that means. So there's little cratering on the Olympus Mons. So as we're seeing, Olympus Mons is a very important structure on Mars, and it has very little cratering, which means that it's geologically young. Judging from the number of impact craters on its slopes, Olympus Mons last erupted some 300 million years ago. So 300 million years ago is still pretty young, because we're talking impact cratering from like maybe a billion years ago or a little over a billion years ago. So, yeah, that's what we mean. Geologically young means that the volcano erupted more. Geologically, Michael Gaming, hi. The sun is flat, it's a light bright. What do you mean? Thank you, Adventures of Austin. Thank you for being here. Thank you so much. We are on the phone. Thank you. Austin's Curiosity Corner. Hey, it's Austin. I subscribed and liked from my second channel. Thank you so much, Austin. That's very kind of you. Thank you. You're like a celebrity to me. Thank you. We are on the phone, yes. So, here's the thing. What we mean by geologically young is that if something is still erupting, like some volcano is going off, like in Hawaii, right? So we have islands in the United States. Well, it's a state now, it used to be a territory. We conquered these islands, poor Hawaii. But Hawaii is actually a very active site. Some of the islands are like geologically active. There's volcanoes happening, erupting. So that's what we mean by geologically active. So if something last erupted within, in this case, 300 million years ago, Olympus Mons, that's still pretty young, because that's younger than the impact cratering. The era of cratering left all of us with a bunch of holes, a bunch of craters, but some of us have done more geological things since that cratering era, and we've covered up the craters. But if you didn't cover up the craters, like the moon, our moon, which is, by the way, a pretty special moon in the solar system. It's one of the giant moons. It's one of the biggest moons in the solar system. And it's an old surface. The moon is not geologically active. It's not geologically alive. So if you don't like volcanoes, you could also go to the moon and lower real estate prices here on Earth. And you would be lighter there. So there's that too. but you know, and it's closer. Valles Marineris is a tremendously long rift valley. So this is another feature of Mars, stretching nearly 5,000 kilometers. So you could live here, Valles Marineris. It's or about 1/4 of the circumference of Mars. So like 1/4 of its circumference is this long rift valley. I'll show you the picture in a bit. It's called the Grand Canyon of Mars. What? Can we get 20 likes? It's called the Grand Canyon of Mars, but this is misleading on 2 counts. First, Valles Marineris is much larger than the Grand Canyon of the Colorado River. So if you're familiar with the Grand Canyon, it's smaller than this Valles Marineris on Mars. Valles Marineris could stretch from Boston to Los Angeles. That's how big it is, with length to spare. Second, Valles Marineris is not the result of erosion by water, because remember, the Grand Canyon is the doing of the Colorado River. That river water erosion is big. Oh, very nice. I hiked the rim to rim of Grand Canyon. I climbed Acatenango. Oh my goodness. So, Valles Marineris is not the result of erosion by water, but instead it's a rift valley caused by convection currents in the mantle pulling the crust apart. So literally the mantle has convection currents going on, pulling the crust apart. So it's not water erosion. It's some crazy stuff happening, pulling the crust apart, which is pretty violent. And it's big. It can stretch from like Boston to Los Angeles and more is the length of this thing on Mars. Okay, this rift valley is no joke. The walls of Valles Marineris have subsequently been sculpted by erosion. The atmosphere is denser in the deep valleys than on the highlands. As noted previously, Mars has similar seasons to the Earth, so that could be a reason you go there, because of its similar obliquity, and by that we mean the tilt of its axis. Of course, it's 25 degrees versus ours is 23.5 degrees, so very similar in that sense. However, the seasons on Mars are significantly affected by the relatively high eccentricity of the Martian orbit. So the Martian orbit is 0.093 ellipticity, okay? Eccentricity compared to the 0.017 for Earth. When Mars is at perihelion, so when Mars is closest to Sun, perihelion, peri is close, so when Mars is nearest to the Sun in its orbit, it is winter in the north and summer in the south. I think that's the case with us too. It is winter in the north and summer in the south. When it is at aphelion, it is summer in the north and winter in the south. As a result of the high orbital eccentricity, seasons are moderated in the northern hemisphere of Mars. Winter occurs in the north when Mars is nearest to the sun, and summer when Mars is farthest from the sun. So this is basically a moderating type of thing. If there's winter when Mars is closest to the sun, and summer when Mars is farther away, what that means is that's exactly right. I just want all the cats and I want the people gone. Exactly, correct. So imagine winter is obviously colder, right? So if you're closer to the sun when you're coldest and you're farther away from the sun when you're hottest, you're actually going to have a moderating type of effect on the planet. So, what is your actual name? Because I tried to look you up on another channel and I couldn't find you. You just want all of us on Mars so you can keep all the cats to use. Yes, I want all the cats. I want the kitty cats to be mine. I want to adopt and birth cats and be their mother and tell them about Mars as bedtime stories like what I'm doing right now. Baji's over there. And I want all the people gone to Mars. Correct. And I want houses here on Earth and forests and walks in the forests. Yeah. Okay, so then, oh, and I like oceans. That's the other thing. I want the oceans to myself as well. Okay, so in the northern hemisphere, or sorry, seasons are enhanced in the southern hemisphere of Mars, since winter occurs there when Mars is farthest from the sun and summer when Mars is nearest to the sun. So the northern hemisphere has moderation and the southern hemisphere has more extreme seasons. The enhanced seasonal temperature swings in the south lead to strong surface winds. So the southern hemisphere of Mars is going to be a bit more extreme, okay? Just warning you if you're going to be in the southern hemisphere of Mars. These winds produce major dust storms that can on occasion envelope the entire planet. Now, it's not a very big planet, but dust storms can envelope the entire planet because of the extreme temperature variations in the southern hemisphere, because of the extremeness of the seasons there, because of the sun being farther away in winter and closer in summer. Hi, Raikudo. Hi, Raikudo. Raikudo, hello. Okay, the polar caps of Mars also vary with the seasons, the area covered by the polar caps. So by the way, just like we have polar regions, right? And they have ice. I mean, we're supposed to have ice in the polar caps. I mean, they are melting, but you know. The polar caps of Mars also vary with the seasons. The area covered by the polar caps can change very rapidly. So if you're going to have a lot of extreme like variations, then the polar caps are also affected and can change throughout the year. So the area covered by the polar caps can change very rapidly, so they must be thin, like a layer of frost. During winter, the temperature is cold enough to freeze carbon dioxide out of the atmosphere. So remember, the Martian atmosphere also has carbon dioxide, just like Venus. Just like us in the past, we also had a ton of carbon dioxide, which we converted to rock by literally doing chemistry with liquid water in the oceans, which converted carbon dioxide to limestone. Thank you, us. But Mars and Venus can't do that because they don't have the liquid oceans that we are abundantly blessed with. Thank you, universe. So what's happening is there's carbon dioxide in the atmosphere of Mars, but that carbon dioxide can actually freeze in the winters of Mars and give you like polar caps that are frozen carbon dioxide, just like we have frozen water in our polar caps, okay? So it's cold enough to freeze carbon dioxide out of the atmosphere in the winter. The Martian polar caps, particularly the southern cap, because remember the southern hemisphere on Mars has more extreme winters because it is farther away from the sun during the winter because of the tilt of the axis of Mars, you know. So in the winter, the Martian polar caps, particularly the southern cap, are large since they're primarily carbon dioxide with which freezes at 150 Kelvin. I want my friends and cats. Some humans are allowed that are my friends. That's it. Okay, so in the winter, the Martian polar caps, particularly the southern cap, are large since they're primarily carbon dioxide, which freezes at 150 Kelvin. So 150 Kelvin, as soon as you get to 150 Kelvins, the atmospheric carbon dioxide can freeze and basically contribute to the polar caps of Mars, especially in the southern hemisphere where it's even colder. Okay, because it's farther away from the sun because of the tilt of Mars, which is similar to the tilt of Earth. Blah blah blah. Whatever. In the summer, the carbon dioxide will sublime. That's what carbon dioxide does. Just suddenly sublimes. That is, it goes directly from the frozen to the gaseous state, but there is still a residual polar cap. The residual summer polar cap is probably frozen water, which sublimes at T equals around 190 Kelvin. Pretty cold. Pretty cold. I hope you like the cold. Bring a jacket to Mars when you go there. At Martian air pressure. So basically, with the Martian air pressure, that's also going to play a role in your phase transition and all that, right? The frozen water will sublime at 190 kelvins. And although at present, yes, I think that life did exist on Mars, even if it was microscopic. It's very well possible because there is evidence of liquid water erosion on Mars. Okay, so if anything has liquid water, traces of liquid water erosion, I would, venture to guess that there might have been life there, but I don't know. That's a research topic that JPL, Jet Propulsion Lab. By the way, if you're interested in these types of topics, especially something like the Mars rover, Mars Europa, these are huge topics of research at the Jet Propulsion Lab, which is affiliated with Caltech. So if you want to study there, work there, whatever, then be my guest. Okay, NASA JPL, NASA Jet Propulsion Lab. Okay, I mean, that's just one example where this is studied. I mean, I'm sure it's studied elsewhere as well, but I know that Europa in particular is a big topic there. Okay, so at present, the water on Mars is primarily in its frozen state. So like I was saying earlier in the live that died, is that Mars, the water is frozen on Mars because it's too cold there. You know what I mean? It's kind of cold. In fact, I'm getting kind of cold now. I want a sweater just thinking about it. Just thinking about it, I would want a sweater now. Okay. Although at present the water on Mars is primarily in its frozen state in polar caps, clouds, or permafrost below the planet's surface. So there's frozen water in the Mars environment, like in its clouds and the polar caps below the planet's surface, but it's too cold, so it's frozen water. There is evidence that liquid water existed more abundantly on Mars in the past. The most obvious form of evidence consists of features on the surface of Mars that have been cut by running water. This is the liquid water erosion that I've been mentioning. Some narrow, dry riverbeds are found on Mars, meandering across the surface of the planet like rivers on Earth. The dried up Martian riverbeds are approximately 3 billion years old. 3 billion, judging from the density of impact craters atop them. In addition to the narrow, relatively orderly riverbeds, there are also broad flash flood channels found on Mars, the result of catastrophic floods rushing across the surface. The outflow channels can be hundreds of kilometers wide and contain teardrop islands. There's even some teardrop islands. Ooh, we'll show you these teardrop islands. I have a picture of them right here. Thus, liquid water existed abundantly on Mars in the past, although it does not at present. This indicates that Mars may once have had a thicker atmosphere and a higher temperature in the past than it does now. So if it had a thicker atmosphere, it could have been warmer there, and that would have allowed the liquid water to exist. Mars has two small irregular satellites called Phobos and Deimos. Fear and panic. God of war and all that, Phobos and Deimos are both heavily pitted with craters, just like our moon has craters too, because these are older surfaces. Moons are sometimes, well, our moon, I'm not saying every moon, but some moons can be pretty geologically dead. So you see those craters even later on, okay? As in even now. As in even much later after the cratering actually happened. So they are also undifferentiated. So these moons, Phobos and Deimos, are heavily pitted with craters, showing a history of collisions with other smaller bodies. I mean, just like our moon has craters too, so that's not surprising. And by the way, the moons of Jupiter that we have also talked about in the past, some of them are very geological. One of them is like the most geologically active site in the freaking entire solar system. And one of the sort of things we look for is if you have a lot of craters, it means that you're an older surface and you did not have enough volcanoes to cover up the craters. But if you have a ton of activity, like geological activity, like volcanoes and things happening, then you're a newer surface and you're not going to have as many craters, okay? These moons are also undifferentiated, indicating they've never been hot enough to melt. So undifferentiated, what differentiation means? Chemical differentiation, where the heavier stuff will sink to the bottom or to the center of the object, and the because these things are mostly spherical, right? And then the lighter stuff will be on top. So like, for example, we have an iron core, which is iron is heavy, but we have sand on the surface, right? So different chemical differentiation is something that we also see quite a bit in the rocky planets, of course, in the terrestrial planets. And if you have undifferentiated objects like these moons, then what that means is that they might not have been big enough, hot enough, because sometimes for something to be very hot, it has to have enough mass for it to be really hot. Like, for example, the sun is really hot and it has a lot of mass. It has 99.9% of the mass of the solar system, or something crazy like that. It might be 98.9 or 99.9, whatever, but that's how much mass the sun has of the solar system as a fraction. So, and it's very, very hot. It has obviously a nuclear reactor in its belly, which is how we get all the heat, like sun energy, all of that, to be able to live on Earth. But basically, if you are not very big, you might not be very hot, which means that you might not have melted enough for your stuff that make you to be very chemically differentiated, where the lighter things are on top and the heavier things are in the bottom, okay? Which is the case with these moons, Phobos and Deimos of Mars. Fear and panic. Goodness. I do not want to associate with this planet. I am more of a Venusian kind of person, if you know what I mean. I'm more peaceful, harmonious, and loving, like a Libra. Gosh. Anyways, Phobos and Deimos both resemble asteroids. That's the other thing, is that asteroids are sort of sometimes undifferentiated, because asteroids are also kind of sort of like small enough where they're not that big and not that hot, and they never got that hot. So they might have cratering, they might have been hit, but they might not have been melty enough to basically have had differentiation, okay? Phobos is on an orbit with semi-major axis of around 9,400 kilometers, which is about 2.76 the radius of Mars. Not only does this put Phobos inside the Roche limit, it also means that its orbital period is 7.7 hours, less than the orbital period of Mars. Since Phobos orbits from west to east, the same direction as the rotation of Mars, this means that future inhabitants of Mars, you guys who will live on Mars, will be able to see Phobos rise in the west and set in the east, while Deimos rises in the east and sets in the west. You're gonna have a moon at all times, my darlings, all times. You'll have either fear or panic in the sky, rising and setting, one after the other, okay? So once again, since Phobos orbits from west to east, the same direction as the rotation of Mars, which this means that future inhabitants of Mars will be able to see Phobos rise in the west and set in the east, and while Deimos rises in the east and sets in the west. So even Mars, by the way, has more than one moon, more than one permanent moon anyways, and that's pretty special. So if you move to Mars, which I highly recommend, highly encourage, well, I don't know if I recommend the planet, but I encourage a movement to Mars, you will have a moon more than here on Earth. No lack of moons. Well, I mean, I guess, you know, sometimes you might not be able to see one because of the sun now, would you? But I don't know. There's more moons there. One more moon. Okay? Should we focus on fixing Earth before spending billions exploring Mars? Now, as human beings, we do have a tendency naturally to explore. So I don't know if we can really stop the exploration, but we can also simultaneously try to fix the Earth. That's my politician answer. I'm not really a politician. But yeah, I would recommend that we always try to improve Earth because this is our home planet and it is really nothing like anything else. I don't know if we can stop exploration because that is the natural human tendency and curiosity, but we should always be kind to ourselves and the planet and try to pick what's best for all of us and this home planet, which I will be inhabiting because all of you will be going to Mars. We need to explore not being selfish. That's very true. All right, I have sniffles because of the swimming, I think. Ooh, I did not have my allergy medication last night. I need to take a Zyrtec. That's part of it. Yeah, I need to take a Zyrtec. We need to explore not being selfish. Would it be ethical to change Mars' environment if life already exists there? You know, given that human beings are generally very predatory, I don't think that they're going to care too much about any life that already exists on Mars, if any. Human civilization is naturally very colonizing. So I think they'll be more interested in colonizing Mars than they will be in saving any life that already exists there. But also, you know, is there any life there? You know, that's part of a research effort anyways, you know. Sinmaido says, bless you. Would it be ethical to change Mars's environment if life already exists there? Hasn't stopped us before. That's very true. I mean, life existed here in the Americas. Did it stop our ancestors? I mean, not mine, because I'm not from here, as in I'm from India, but has it stopped people in the past from colonizing Earth and parts of Earth that they're not from? No, then they're gonna do the same thing on Mars probably. How hard is it to terraform? Hello, Georges. Hello, Google Rewrites. Hello. I don't want my Google to start talking to me again. Hello, Adventures of Austin. Hello, everybody. Thank you so much for being here. Hello, Raikudo. Hello, everybody else. Thank you for being here. I want to finish my protein shake. They have a snack. They have a snack that is getting deposited at this time with the auto feeder. Yay! Ooh! Also, feel free to do a super chat, guys. Can someone do a super chat? Sorry to ask, but I gotta, I have to ask for these things. Can someone do a super chat, and can someone please like the live, and can we get 20 likes? Every time an orca eats the Earth's soul heals a bit. Yay! How long does it take, Tub? How long does it take to get to Mars from Earth? I think it takes about a year. So this is one of the big reasons why I wish that Venus was more habitable, because Mars is a lot farther away. Like it takes like a month to go to the moon, right? And it takes maybe a couple months, 3 months maybe to go to Venus. But for Mars, it's going to take a year. That's a long ways away. Hey Google, how long does it take from Earth to go to Mars?
On the website space.com, they say, a one-way trip to the red planet would take 9 months, but a return journey would be around 3 years. While these estimates provide a general idea, the actual duration is influenced by several factors.
There you go. Takes like 9 months to go there, 3 years to come back. Roughly, if something takes a year, that's another whole reason why I wouldn't want to go to Mars. It's going to take too long. Nearest planet still so far. Venus is the nearest planet, not Mars. Mohit, Venus is closer to us than Mars. Venus is same size, almost the same size. It's smaller than Earth. Earth is the biggest rocky planet, or the biggest terrestrial planet out of the 4. Venus size, radius, and mass is similar to Earth. And Venus is closer to Earth than Mars, okay? No worries. No worries. So that's what I mean. It's going to take longer to get to Mars than to Venus. So I wish that Venus was more habitable and did not have a poisonous atmosphere, or otherwise Venus is the obvious choice. But then again, we can talk about Venus the next time. Again, we have talked about Venus in the past here. But Venus does have other issues too, though. Venus is very hot. Very hot. Very hot indeed. Closer to the sun, more hot. Has the poisonous atmosphere, very thick poisonous atmosphere, Thank you so much everybody for being here. Please do like the live. Can you double tap the screen and like the live? I asked my parents if I could do a super chat, but they said you would have to pay for it, and I'm kind of broke. Aw, that's okay. Thank you, honey. Don't listen to him. I'm the real one. Seriously? Because of your username, my Google thinks I'm talking to him. I have a man Google. Yarnaby. Hello. Hi, Yarnaby. Hi, Yarnaby. How are you doing? Mohit says, oh yes, sorry, no worries. I asked my parents. I'm happy here. Earth is my home, yeah. Ooh, you know what you could do? Adventures of Austin, I'll make you a mod. How about that? You've done well. You have been asking a lot of good questions, so I'll make you a mod. Do you want to be a mod? Adventures? Yay. Yay. Yarnaby says I'm doing good. Very nice, Yarnaby. Adventure says sure. Aww. Getting that promotion. Adventures of Austin asked a lot of good questions, so you're gonna get the promotion. Adventures. I'm gonna make you a standard moderator. There you go. Now when Adventures of Austin comments, it's gonna look blue. Because Adventures of Austin is a mod. And so he or she or they get a special blue icon. Yay. Getting that promotion, yes. Nice seeing you. Bye, Mohit. Nice to see you too. Please do come back. Like, share, subscribe. Can you please tap the screen before you go, and can we get 20 likes? Can we? Can we get 20 likes? What's the coolest fact about Mars you've read so far? I actually really love, like more than I thought I would, I love the tilt of Mars. I love that the orbital axis tilt is 25 degrees, which is similar to ours, 23.5, which means that Mars will have similar seasons. Of course, much colder, but still, I like that to be sort of relatable. Like a lot of the planets are quite different than Earth, you know, like there's some crazy things happening. Like we'll talk about Venus more next time, but Venus's freaking orbit and rotation and everything is so different. So like I love Venus. I'm a Libra, as astrologically speaking, ruled by Venus. So I like Venus. That's my favorite planet. But gosh, is its like orbit and rotation and speed of rotation is so alien to me. It's so very different than the Earth, you know? So I think I like, it's cool that, that the Mars, what do you mean? What do I call it? The Mars, orbital tilt, the axis, tilt of its axis is very similar to ours on Earth. And so the seasons are a thing on Mars, just like us. And the only thing is that it's going to be cooler there, so bring a jacket when you all move to Mars, okay? Yay! Another planet should be alien to you. Agreed, my love, agreed. All right, any more questions? And can someone do a super chat? And can someone like the live? And can we get 20 likes? Now I'm gonna watch every live stream, says Austin. Austin, you really made my day today. Thank you so much for being such an engaged subscriber and live stream commenter. It's my pleasure making you a mod and giving you this promotion. You've earned it. Love your enthusiasm for these topics. Love it, love it, love it, love it. Hi Raikudo. Hi Sinmaido. Thank you for making me a moderator. You're the best. Thank you, honey. Be kind to most people. Give them a chance if they're being weird. I'm like very lenient with people on the live. My mods, sometimes my mods are very strict with people. And they will like time them out left and right. So I would say my recommendation is just kind of give them a couple chances, tell them not to do it if they're being weird, and then you can time them out, okay? Don't time them out right away because that could be kind of discouraging. And also I do want people to view these live streams and sort of participate and whatnot and engage. So yeah. I'm actually in 6th grade and love learning about this stuff. Oh my gosh. Well, welcome to you, my 6th grader. That's a big boy. That's a big boy. 6th grade. 11? Are you 11 or 12? I'm subbed and all I got was told to get off the planet. Rewrites. I don't want to say your first name, Google, because my Google would start talking to me unprecedented, like unwanted, like. But indeed, I wanted to tell you that you should get off the planet. Rewrites history. Oh, my children are making some sounds. I'm almost 12. Aww. Austin is almost 12. You're so big. You're so old, Austin. Love it. I'm also definitely buying that book you read. Oh, of course. And you should, you know, Austin, Sinmaido says, how many children do you have? I have the 3. Thank you, universe. Touch wood. I have 3 kids who are cats. And I birthed them all. So this book is called Foundations of Astrophysics by Barbara Ryden and Bradley M. Peterson. It's a college, astrophysics astronomy book. And just because I'm 12 makes me old. I was just joking. You're still very young. I think that movie, The Martian, might be good for Austin to watch. Austin, have you seen The Martian, the movie Martian? By the way, so Austin, this book is a college astronomy astrophysics book. You're most welcome to buy it. But also, you should go check out my older live streams. If you check out the live streams, let me just give you a few live streams to watch, okay? Because I feel like you'll get a lot of value out of those live streams and you may not have to buy the book right now. But at the same time, of course, if you want to, then you can. And I know the authors of this book as well. They are on my Facebook. So if you follow me on there, I can even introduce you, maybe. And you can try to go and see what you can learn from their websites and things like that. So I'm just giving you some more options in case you're interested in these topics of astronomy, astrophysics, and physics. There are resources on the internet that you can look up, okay? They're very nice people, these 2 professors. And you know what you should do? You should definitely try to do some kind of like summer research thing at a university or something. I think that'll be really helpful for you going forward. Get yourself involved in something like researchy, some like project that you can do, even early on, because you're still very young. But if you're interested in these topics, there's really a lot to do and learn, okay? So I hope you get into it. We need more academics. Okay, so if you go to my channel and if you go to the live tab on my channel, I live in South Carolina, so there's not very many places to go and study about this stuff except for like 2 colleges. I know South Carolina. I went to NC State for my undergrad. So I recommend NC State. I can help you with some introductions to the physics department at NC State if you're interested. The guy that wrote that movie wrote another book, have it but didn't finish it. It's about a tourist colony on the moon. A tourist colony. My oh my. I say everybody just move there. Especially the annoying ones. I say annoying people all move to the moon or to Mars. Go for it. So Austin, a while ago, well, all the lives might be interesting to you, especially we've been covering a lot of cosmology, black holes, universe, Big Bang, all that stuff recently. But if you especially like the planets, then I've got a number of them that I can tell you about. Let me share some of my planet specific lives. My mom is gonna be shocked when she figures out that you made me a moderator instead of us. Why would she be shocked? What do you mean? Why would she be shocked? All right, so I'm gonna share this particular live to my channel as a post right now for you, Austin, and you can go check it out. So what's your username again? Adventures of Austin. Let's see. Can I find you? What's your username? Sachi Mama, I hope you didn't poop on the floor, baby. Ah, I see. I'm trying to look up your... So, I am sharing this... Thank you for liking the live. Can we get 20 likes? Because she would be proud of me. Aww. I would be too. You should be proud of you. Very nice. So I'm gonna share my planets live, one of them, with you on my post on YouTube. I'll tag you, and you can go check it out. Okay, there's a lot of interesting things that we discussed in these lives. And let me tag you on a different one as well. Jovian planets, that was another. So we actually covered all of the planets already on the previous lives. And so I really want to share them. It's been a while. It's been a while. Hi, good morning. Hello. Thank you for all the emojis. I'm sorry, but can you hold up a little piece of paper or something on it that says, "Thanks, Adventures of Austin"? My mom will be proud of me. Okay, give me 1 second. Watch this. I'll tag you again. Hello, everybody. Sorry, I'm tagging him. Oh, it's not letting me. Okay, let me do it this way. Let me share it. Ooh, can I share it? Can I share? Oh my God. Thank you for the hearts. Thank you so much. Hello, everybody. Thank you so much for being here. Okay, and then let me create post again. These are the Jovian planets. So you should definitely check out my lives that have information about the terrestrial planets and the Jovian planets, and associated lives which talk about the moons of those planets, the giant moons of the solar system. Like there was a period, maybe in the month of like December, January-ish, where we constantly covered the planets and the moons and the solar system a lot. And so if you're interested in that, then then that's going to be the types of live streams that you might enjoy a lot. That's been done already, and it's posted and under the live tab. Okay, so I'm tagging you in some of these, when I do my create posts, when I do posts for my channel. And then, hi Yarnaby, what Arabic country are you from? Are you asking some of these people on the chat or what? So the other thing is, recently we've been covering cosmology, the universe, all that stuff. So if you're interested in cosmology, you can find a lot of that as well under the live tab. But there's a lot of episodes. So yeah, you can look at it after this live because I'm just like doing it now, but you can see it later. Wait for this live to finish. Then you can go check it out. So is it late for you, by the way? Isn't it your bedtime? I guess I don't know where you're from, so which is fine. You don't have to tell us. Okay, so I shared Planets Plus Kitties with you. I shared Jovian Planets Plus Kitties as well with you. Oh my God. And then there's also the lives that are Big Bang, Universe, and all that stuff. So it's way past my bedtime. About 4 hours passed. Oh my gosh, I'm gonna start the live. I'm gonna start the lives earlier. This is too bad. This is too much. I'm gonna start the lives earlier because yeah, it's kind of rough, isn't it? It's kind of late. But at the same time, sometimes people are like busy with their dinners and whatnot, and so I feel like it's really random when people are able to join sometimes. You know what I mean? I will look at all the live streams. Yes. So look at the previous live streams, especially the ones I tagged you in, and then leave your comments. If you have any questions, leave your questions in under the videos, because then I can see what you're asking about and try to cover that as well in the upcoming episodes and upcoming live streams. So it can be sort of a back and forth, don't feel like don't feel like it's only like I take into account the input I get from the people who are really interested in these topics. So feel free to ask any questions and further comments and stuff in the old live streams as well in the old videos, because that will also help me see where you're interested. That would be really helpful. Okay. I'm trying to be as informative as I can, especially for the young kids who might be studying this stuff going forward. Okay. Hopefully that helps. The guy with the name in Arabic, about 4 hours passed. Okay. Well, we will wrap this up soon here so that we can all go to bed. Was hoping he's from Morocco. Do you have a question? Do you have a question about Morocco? What's your question? Maybe I would know. So can I do the paper thing tomorrow, Austin? Is that okay? Maybe you can come back and we can do that tomorrow, because I want to actually wrap up here. Ooh, another very interesting one is exoplanets. Another. I'll tag you. Okay. Let's see. Do I have a pen? We going to bed. You're going to Mars. Pack your bags. I'm staying on Earth. You're going to Mars, all of you. 1 second. I'll be right back. I don't have my pen here right now. My favorite country? What's your favorite country? Mars? It's a planet, guys. There. Can you read that? There, you can screenshot it. Morocco. What about it? Thanks, Austin, and good morning, Austin's mom. I know, it's being reversed, isn't it? Too bad. Right. Hi, Sachi. There's a kitty cat here. There's a kitty cat here. Yeah, you can take a screenshot and then just like reverse it. Hi. I birthed you. I birthed you. Okay. She's right here under me, brushing up against me. I definitely want the cats to be on Earth. People, optional. Oh my gosh. All right. I'm gonna, here. I'll show you guys the teardrop islands. And I'll do some dishes in the background. Okay. I'll do some dishes in the background. And I'll show you some of these islands. On Mars, that is. Okay. There is a cat planet. I have a crested gecko and a chameleon. Oh my gosh. And 2 dogs. There's a cat planet, Protopia. Here's the teardrop islands on Mars, okay? So in this region shown in this image, water flowed from left to right. The crater that diverted the flow to form the teardrop island on the left is 8 kilometers in diameter. Here's this teardrop island that's on Mars, okay? You can screenshot this one too if you're interested. But that's what this is. All right, guys, I have to go to bed. Thank you so much for being here. Really appreciate you all. Thank you, thank you, thank you. Please do like, share, subscribe. Please do share my videos with friends if they're interested. Please do come to the live again. Please do enjoy watching our shorts, videos, clips, lives, all of that. Stay tuned to the channel. I'll keep sharing and posting things and whatnot. Thank you so much. Have a good night. Good night. Love you, miss you, and good night, and thank you. Oh, thank you. Good night. Bye, kiddos. Hi, Legend Lion Kings. Thank you so much for being here. Can we get 20 likes? Thank you. Bye. Bye, bye, bye.